Hello, welcome to this lesson on Venn diagrams. Today we're going to be calculating probabilities with Venn diagrams. So let's jump right in. So we're going to be using the set notation again for this lesson, okay? So if you're not totally happy with that, watch the last lesson of set notation. Hopefully that'll clear some things up for you. But it's a very tricky topic, okay? So don't worry if you don't get it straight away. It takes a while to understand how it is, and I find it really hard to work these out in my head. So it's really useful to write them down on a bit of paper with two pens of two different colors. Okay, so last lesson, again, we did set notation. So we've got the Greek letter Z representing all of our Venn diagrams, everything in the rectangle. And we had event A and event B. And these events can be anything. So last lesson, we talked about event A and event B. And now we're looking at probabilities. So the notation we use is P of A. And that's just P bracket and whatever event we're trying to find the probability that goes inside the bracket. So P of A simply means finding the probability of event A occurring. Probability P of B just means probability of event B occurring. P of A prime is the probability of event A not occurring. Probability of B prime is the chance of event B not happening. And then we had union and intersection. So union means or. So A union B just means event A or event B occurs. Okay, so you would include all of the numbers in the Venn diagram under these two events because you're asking if it's A or B. A intersect B is the probability of two events happening together. They do happen. Okay, so it's the probability of event A and B occurring, and that is represented by the overlap of event A and B. And we've also got some honorable mentions now, some slightly different ones, but if we were to go through all the different variations, we'd be here forever. So there's two extra ones here I want to talk about. So the first one is A intersect B prime, and that is the event A and not B occurring. So it is the overlap of event A and not B. And a simple way of explaining this is that only event A occurs. And for the second one, we've got A prime intersect B prime. And again, if you were to read this one out, it literally is event not A and not B occurring. So it's the overlap or the intersect of not A and not B. So that is everything except A and B. So neither event A or B occurs. Okay? So let's have a look at some example questions for finding probabilities with Venn diagrams. So if we have our Venn diagrams here now, so we've got 30 students. We're surveyed about whether they studied history or geography, and a student is picked at random. So what is the probability of G? And G is just a student who studies geography. So what is G represented in the Venn diagram? Well, it's just the circle associated with G. Therefore, we know that 11 plus 6 people do geography. That's 17. Therefore, to find the probability of who studies geography, picking a random student and then studying geography, the P of G is simply 17 out of 30 because there's 30 students in total and 17 of them study geography. Now turn this into a fraction, 17 over 30, solve it as a decimal, then there you go. That's your answer as a probability. So 0.57 is a chance of 0.57 of picking a random student that they study geography. Let's have a look at the next question now. What's the probability of H intersect G? So we're looking for H and G. So we're looking for the overlap of event H and event G. Well, if that's event H and that's event G, the overlap is the green area in the middle now. So now we've got that. All we have to do is count the numbers highlighted. Well, there's 11. Therefore, the probability of finding someone who does history and geography, or H intersect G, well, there's 11 of them, and there's 30 people in total, so it's 11 out of 30. 11 divided by 30, that is 0.37 to 2 decimal places. It would be 0.3666 recurring, all right? Let's have a look at another one. So 50 students were surveyed about whether they studied art or drama. One student is picked at random. What is the probability of A prime? and that literally means not A. So a student who doesn't do art. Well, if we highlight the Venn diagram, that's everything except the event A, the circle A. And if we add up all those numbers outside of that or in the shaded area, we've got 5 and 15. Therefore, 20 people don't do art. Therefore, the probability of picking a student who doesn't do art is, well, there's 20 of them, so 20 out of 50. Put into a fraction, solve the fraction, turn it to a decimal, 0.4 chance. What about the next one now? Probability of A union D. Remember, union means or. So we're trying to find the probability of a student studying art or drama. Well, if we highlight the art people and the drama people together, we've now highlighted everyone who either studies art or drama. Add up the numbers. 10 plus 20 plus 5 is 35. So we have 35 people who do art or drama. 35 out of 50. That's our probability of picking an art or drama student. Put it into a fraction, solve it. Probability of picking someone who does art or drama is 0.7. Last example now. We have 20 students who were surveyed about their hair color, whether it's curly or brown. And a student is picked at random. What is the probability of C prime? Or in other words, not C, because that's what C prime represents. Well, let's highlight everything that's not C in the Venn diagram. There you go, everything outside of circle C. If we add those two numbers, 2 plus 7 is 9. So we have 9 people who do not have curly hair. Therefore, if there's 20 pupils in total, the probability of picking someone without curly hair, there's 9 out of 20 chance. Turn it into a fraction, solve the fraction, 0.45 chance of picking a student who doesn't have curly hair. Last one now. What is the probability of C intersect B prime? Now this is a tricky one, okay? So if we read it as is, C and not B. So C and not B. Remember, and means intersect, whereas we're looking for the overlap between C and not B. So if we put C on here now, so that's people who have curly hair, and this in blue now is people who are, on green, sorry, people who don't have brown hair. Now we can see it covers most of the Venn diagram, but there's only one portion that is highlighted by both C and not B, and that is it turns C into sort of a crescent shape, which in other words, it means we're only looking for people with curly hair. Again, count the numbers. Well, there's only one number in there, that's 6. Therefore, 6 out of 20, turn it into a fraction, 6 over 20, simplify the fraction, turn it to a decimal. There's a 0.3 chance of picking someone who has curly hair and not brown hair. Or in other words, they only have curly hair. Okay, let's have a look at the main task. So here's your questions. Pause the video. I highly recommend getting a bit of scrap paper and having 2 different colored pens or pencils, just so when you're coloring your Venn diagrams, you can see what you're actually trying to find with the overlaps or the unions, adding them all together, okay? So pause the video, have a go with these questions. Okay, here are your answers. Very well done if you got those all right. Let's have a look at the checking question now. So 60 pupils were asked if they walked to school or got a lift. 40% of all the pupils are girls. 18 boys walk to school. And the probability of picking a student at random who is a female and walks to school is 1/3. And you've got 5 questions here. Complete the Venn diagram. How many girls walk to school? How many pupils walk to school? A pupil is chosen at random. What is the probability that they are a boy who walks to school? And a girl is chosen at random. What is the probability they get a lift to school? So pause the video and have a go at this question. Okay, so start at the top now. If we start on the left, so rather than answering the question, let's start on the left first, because we're going to complete the Venn diagram using this information. So 40% of the pupils are girls. Well, 40% of 60 is 24. Therefore, we can write in, we can't fill in the Venn diagram just yet, but we can say there are 24 total girls. So we can put that in bracket at the top there. 18 boys walk to school. Well, we've already got that information in the Venn diagram because they're not in the girls circle. So that must mean they're a boy and they're contained within the walk to school circle. So therefore, they are a boy who walks to school. Now, the probability of picking a student at random who is a female and walks to school. Now, this area on the Venn diagram is represented by the overlap because they are both a girl and they walk to school. So it's that intersect between girl and walk to school. And if the chance of picking someone in this section is a third, then that means they represent a third of the total population of the 60 pupils. A third of 60 is 20, either 60 divided by 3 or a third times 60, either way. We can put that number in. And then working out the final one, now final part's the Venn diagram. We know, well, we need to find this number in the girl circle, the other number in the girl circle. Well, we know that all the numbers in the circle have to add up to 24, because there's 24 girls in total. So 20 plus something is 24. Well, that number's 4. Again, thinking about outside of the two circles now, we need this number. We don't know what this number is, but we know the total number of pupils, that's 60. And we know 3 other numbers, and apart from the missing number, we can describe, we can pretty much identify all the numbers of pupils represented in the Venn diagram, apart from this one. Therefore, all of the numbers plus this missing number have to add up to 60. And that number is indeed 18. And if you were to put one last number in this Venn diagram, it would maybe be the total number of pupils who walk to school. And all you'd have to do there, you'd have to add up the numbers in the walk to school circle, which is 20 and 18. That would give you 38. So getting rid of the colours now. How many girls walk to school? Well, we've inadvertently answered that. Well, we can see this now. If we look at the girl circle, the number 4 represents those who don't walk to school, and the number 20 represents the girls who do walk to school. So it's 20. How many pupils walk to school? Well, you can either look at the walk to school circle and add up all of those numbers, or we can just look at the total number of pupils that walk to school that we've already calculated, and that's going to be 38. Now, if a pupil is chosen at random, what is the probability they are a boy who walks to school? Well, first of all, we need to think about what part of this Venn diagram are we looking at? We know the two circles are girls and walk to school. Therefore, if it's not in the girl circle, there have to be a boy. So we're looking for a boy who walks to school. So someone outside of the girl circle, but in the walk to school circle. And that is this area here, number 18. So if we've got 18 boys who walk to school and there's 60 in total, turn it into a fraction, solve the fraction, 0.3. Job done. And then the last question now. If one girl is chosen at random, find the probability that they get a lift to school. So this is a slightly different question because we're not asking about if a pupil was chosen at random. We're asking if a girl, if a girl was chosen if a girl, we're already looking at the group of girls and we pick one of the girls at random. Therefore, we need to look at the total number of girls, which is 24. There's 24 girls in total. Therefore, if they get a lift to school, that's only represented by 4 of them. 4 out of 24, turn it into a fraction, solve the fraction, and you get your answer of 0.17 to 2 decimal places, or 0.166666. So, very well done if you got that right. Very tricky question. And yep, that's Venn diagrams. Set notation is definitely the hardest part. So if you understood that, very well done. But we've got plenty of time to go over that in the future. Thank you, guys. I'll see you next lesson. Bye now.